The ampacity of a 4 American wire gauge aluminum conductor with 3 conductors in a raceway or cable or earth is 95 amps. This rating is based on the National Electrical Code, specifically Table 310.16 in the 2020 Code and similar tables in other editions. It assumes an ambient temperature of 30 degrees Celsius, which is 86 degrees Fahrenheit, and that the conductors are insulated with a rating of 75 degrees Celsius or higher. The 75 degrees Celsius column is typically used for terminations rated for that temperature, which is common in residential settings. It is important to consult the specific edition of the National Electrical Code, or NEC, that is enforced in your jurisdiction, as code requirements can change between editions. Also, it is crucial to understand that this ampacity rating assumes certain conditions, such as the ambient temperature and the number of current-carrying conductors in a raceway or cable. If these conditions change, the ampacity of the conductor must be adjusted accordingly. For example, if the ambient temperature is higher than 30 degrees Celsius, the ampacity must be derivated using correction factors provided in the NEC Table 310.15 Born. Similarly, if there are more than 3 current-carrying conductors in a raceway or cable, the ampacity must be derivated using adjustment factors provided in NEC Table 310.15 Cone. These derating factors are applied to prevent the conductors from overheating, which can damage the insulation and potentially cause a fire. Firstly, consider the ambient temperature. The NEC ampacity tables are based on an ambient temperature of 30 degrees Celsius. If the ambient temperature is higher, the conductor will be less able to dissipate heat and its ampacity must be reduced. Correction factors are provided in the NEC to adjust the ampacity for different ambient temperatures. These correction factors are typically expressed as a percentage. For example, if the ambient temperature is 40 degrees Celsius and the correction factor is 0.91, the ampacity of the conductor must be multiplied by 0.91. Secondly, consider the number of current-carrying conductors. The NEC ampacity tables are based on the assumption that there are no more than 3 current-carrying conductors in a raceway or cable. If there are more than 3 current-carrying conductors, the conductors will be less able to dissipate heat and their ampacity must be reduced. Adjustment factors are provided in the NEC to adjust the ampacity for different numbers of current-carrying conductors. These adjustment factors are also typically expressed as a percentage. For example, if there are 4 to 6 current-carrying conductors and the adjustment factor is 0.80, the ampacity of the conductors must be multiplied by 0.80. Thirdly, consider voltage drop. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or fail to operate properly. The NEC recommends that voltage drop should not exceed 3% for branch circuits and 5% for feeders. To calculate voltage drop, you need to know the length of the conductor, the current flowing through the conductor, and the resistance of the conductor. The resistance of the conductor can be found in the NEC tables. If the voltage drop exceeds the recommended limits, you may need to use a larger conductor. Fourthly, consider the type of load. The type of load that the conductor will be supplying can also affect its ampacity. For example, motors and other inductive loads can draw a large amount of current when they start up. This inrush current can cause the conductor to overheat if it is not properly sized. The NEC provides specific requirements for sizing conductors for motor circuits. Fifthly, consider the termination temperature rating. The termination temperature rating is the maximum temperature that the conductor insulation can withstand at the termination point. The NEC requires that the conductor be terminated at a device that is rated for the same temperature or higher. For example, if the conductor is rated for 75 degrees Celsius, it must be terminated at a device that is rated for 75 degrees Celsius or higher. Using a device with a lower temperature rating can cause the insulation to overheat and fail. Sixthly, consider the type of raceway or cable. The type of raceway or cable that the conductor is installed in can also affect its ampacity. For example, conductors installed in a conduit that is exposed to direct sunlight will be subject to higher temperatures than conductors installed in a conduit that is buried underground. The NEC provides specific requirements for directing conductors installed in different types of raceways and cables. 7. Consider the conductor insulation type. Different insulation types have different temperature ratings. Common insulation types include THHN, THWN, and XHHW. THHN and THWN are rated for 90 degrees Celsius in dry locations and 75 degrees Celsius in wet locations, while XHHW is rated for 90 degrees Celsius in both dry and wet locations. However, even if a conductor has a 90 degrees Celsius insulation rating, the ampacity is often determined by the temperature rating of the terminals it connects to. Most residential breakers and equipment are rated for 75 degrees Celsius, so the 75 degrees Celsius ampacity column is typically used. 8. Consider bundling of cables. When multiple cables are bundled together, they generate more heat than if they were run separately. This is because the heat from each cable is trapped by the surrounding cables, reducing the ability to dissipate heat into the surrounding air. The NEC requires that the ampacity of conductors be derated when they are bundled together. The amount of derating depends on the number of current-carrying conductors in the bundle. 9. Consider continuous loads. A continuous load is a load that operates for 3 hours or more at a time. The NEC requires that conductors supplying continuous loads be sized to carry 125% of the continuous load current. This is to prevent the conductors from overheating due to the sustained load. For example, if you have a continuous load of 20 amps, you would need to size the conductors to carry at least 25 amps. 20 amps x 1.25 equals 25 amps. 10. Consider conduit fill. The NEC limits the number of conductors that can be installed in a conduit. This is to prevent the conductors from overheating and to allow for easy installation and maintenance. The conduit fill requirements are based on the size of the conduit and the size and number of conductors. The NEC provides tables that specify the maximum allowable conduit fill. The National Electrical Code, or NEC, is a comprehensive set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA, and is updated every 3 years. The NEC is not a law, but it is widely adopted by state and local jurisdictions as a basis for their electrical codes. The purpose of the NEC is to protect people and property from electrical hazards. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is a complex document, but it is essential for anyone who works with electricity to understand its requirements. It is important to consult the latest edition of the NEC to ensure that your electrical work is safe and compliant. Furthermore, the specific application of the 4 American wire-gauge aluminum conductor is also important. If it's used for service entrance conductor, local utility regulations might have specific requirements that exceed the minimum NEC standards. These requirements could dictate the size of the conductor based on the overall load calculation of the dwelling. The load calculation considers all the electrical demands of the house, including lighting, appliances, heating, and air conditioning. The service entrance conductors must be sized to handle the total calculated load. Additionally, consider future expansion. If you anticipate adding more electrical loads to your home in the future, it's wise to install service entrance conductors that are larger than their minimum required size. This will avoid the need to upgrade the conductors later on, which can be a costly and disruptive process. It is also important to ensure that the service equipment, such as the main breaker and the meter socket, are also rated for the larger conductor size. It is always a good idea to consult with a qualified electrician to determine the appropriate size of service entrance conductors for your home. An electrician can perform a load calculation, assess the existing electrical system, and take into account any local utility requirements. They can also ensure that the installation is done safely and in accordance with all applicable codes and regulations. When working with electricity, safety should always be your top priority. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock and fire hazards. Always turn off the power at the main breaker before working on any electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. Remember that the 95 amps rating is a general guideline, and the actual ampacity of the 4 American wire gauge aluminum conductor may vary depending on the specific installation conditions. Always consult the NEC and a qualified electrician to ensure that the conductors are properly sized and installed. Overcurrent protection is another crucial aspect of electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect conductors from overheating and potentially causing a fire. These devices are installed in the electrical panel and are sized to match the ampacity of the conductors they protect. If the current in a conductor exceeds the rating of the overcurrent protection device, the device will trip or blow, interrupting the flow of electricity and preventing the conductor from overheating. It is important to choose the correct size of overcurrent protection device for the conductors. If the device is too small, it will trip or blow unnecessarily, causing nuisance outages. If the device is too large, it will not provide adequate protection and the conductors could overheat and cause a fire. The NEC provides specific requirements for sizing overcurrent protection devices for different types of conductors and loads. The overcurrent protection device should never be rated higher than the ampacity of the conductor it is protecting. In the case of a 4 American wire gauge aluminum conductor with an ampacity of 95 amps, the overcurrent protection device should not exceed 95 amps. It is common practice to use a slightly smaller overcurrent protection device to provide a margin of safety. For example, you might use a 90 amp or 80 amp breaker to protect a 4 American wire gauge aluminum conductor. Grounding is another essential aspect of electrical safety. Grounding provides a path for fault current to flow back to the source, which helps to trip the overcurrent protection device and prevent electrical shock. The grounding system consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor, which connects the grounding electrode to the electrical panel. All metal enclosures and equipment must be properly grounded to ensure that they are at the same potential as the earth. This helps to prevent electrical shock if there is a fault in the electrical system. The NEC provides specific requirements for grounding electrical systems. It is important to follow these requirements carefully to ensure that the grounding system is effective. Always remember to consult the most recent edition of the NEC and any applicable local codes before performing any electrical work. These codes are designed to ensure the safety of people and property, and it is important to follow them carefully. If you are not comfortable working with electricity, it is best to hire a qualified electrician to do the work for you. They have the knowledge and experience to perform the work safely and in accordance with all applicable codes and regulations. When dealing with electrical systems, it is always better to be safe than sorry. Taking the time to understand the NEC and follow proper safety procedures can help to prevent electrical shock, fire hazards, and other serious problems.